Welcome to the Explainer. Today, we are diving deep into a really radical new framework for reality called hyperbrane relativity, or HBR. We're going to focus purely on its scientific architecture, and it proposes that everything we experience, time, gravity, even the quantum world, might just be shadows of a deeper and, honestly, a much simpler geometric reality. So here's our game plan. We'll start with HBR's brand new geometry, then see how it totally redefines time and cosmic expansion, and from there, we'll explore how it could, just maybe, unify gravity and the quantum world with a single, incredibly elegant idea. Let's get into it. All right, first things first, HBR isn't just trying to put a band-aid on modern physics. No, it's proposing a complete teardown and a rebuild from the ground up, starting with the very geometry of reality itself. And this right here, this is the central question HBR forces us to ask. What if the biggest mysteries in the universe, time, gravity, all that quantum weirdness, what if they aren't fundamental things at all, but just artifacts? Just byproducts of our limited, three-dimensional point of view. Okay, let's get to the cornerstone of the whole theory. It introduces a new fourth spatial dimension that completely changes everything we thought we knew about time. So to even begin to get your head around to HBR, you kind of have to forget about space-time for a second. The theory starts by saying that the fundamental reality, what it calls the bulk, is a timeless, four-dimensional space. Just think of it like an infinite block of glass. You have coordinates x, y, z, and now w. But when just doesn't exist here. So where are we in all this? Well, our entire 3D universe is what HBR calls a hyperbrane, but don't think of it like a thin sheet of paper. It's more like a thick bubble, a whole volume, that's constantly moving through that 4D space. We are inside that bubble, and its perpetual motion is absolutely key to everything. And this leads to a pretty mind-bending idea about time. The tick-tock that we feel, what's called brain time here, it isn't fundamental. It's an emergent property, kind of like how the forward motion of a movie comes from a reel of film moving through a projector. Our universe's movement along that fourth y-axis literally creates our perception of time. If that motion stopped, our time would just freeze. Meanwhile, the bulk time is like the physics engine of the projector itself, the unchanging rules running the whole show, which we can never, ever see directly. Now, if that foundation is correct, it has some really profound consequences for cosmology. It completely flips the script on the expansion of the universe. So how does this reinterpret cosmic expansion? Well, the standard model says space itself is stretching, pushing galaxies apart. But HBR says, no, that's not it. It's the opposite. Our entire reference frame, our ruler, is actually shrinking. So when we look out at a really distant galaxy, we're seeing it as it was in the distant past when it was larger. From our smaller, present-day perspective, that difference in scale creates the illusion that it's rushing away from us. And here is where that radical idea really pays off. This isn't just some philosophical game. This conceptual shift actually allows HBR to derive the Hubble constant, a fundamental number in cosmology that until now, we've only ever been able to measure from first principles. It becomes this simple ratio. Our universe's velocity through that w-axis divided by some characteristic length in that higher space. And the implication of that equation is just stunning. For the calculated Hubble constant to match what we actually observe in the sky, there's really only one possible conclusion. Our entire 3D universe has to be moving through that fourth dimension at the speed of light. The ultimate speed limit, c, isn't just about how fast light travels. It's the speed at which our reality itself is being generated, moment by moment. This completely reframes the whole idea of the Big Bang. Instead of a single explosive starting point in time, HBR suggests it's more like a continuous process of emergence. Think of a river constantly flowing from a higher dimensional source. The beginning we see isn't the start of time itself. It's just the edge of our bubble, that boundary where our 3D reality connects to the 4D bulk. All right, so now let's see how this exact same geometric thinking can be used to redefine mass and gravity, and maybe, just maybe, solve one of the biggest puzzles in cosmology, the mystery of dark matter. So in HBR, mass isn't some fundamental property of matter. It's a process. Our brain's constant motion through a 4D energy field, which the theory calls Q, compresses that energy. When that energy density gets high enough, it hits a critical threshold and, poof, it materializes as stable mass. It gives us this really literal interpretation of E equals mc squared. Matter is condensed motion. If our universe stopped moving, mass would just dissolve back into pure energy. This completely flips our understanding of gravity on its head. It's not a pull, it's a push. It's a reactive force. The particles making up the Earth are resisting our universe's constant motion through the fourth dimension. And that resistance is what's pushing the ground up into your feet right now. In a really profound way, this makes Einstein's equivalence principle real. Gravity is acceleration, because it's the result of our entire universe accelerating through a higher dimension. And you know what? This new model of gravity offers a really compelling solution to the dark matter problem. By calculating the effects of this 4D push on our 3D reality, the theory predicts that gravity should just behave differently on galactic scales. It naturally produces the exact flat rotation curves we see in galaxies, which is our main evidence for dark matter, without needing to invent a single new invisible particle. It just works. So what happens when we apply the same geometric logic not to the biggest things, but to the smallest? Well, it reveals a potentially elegant solution to the foundational mysteries of quantum mechanics. So how does HBR get rid of all the quantum weirdness? Well, it proposes that what we call a particle is actually just a projection, a shadow of a higher dimensional object. Imagine a helix, kind of like a spiral staircase, existing in 4D space. When our 3D reality slices through that helix from the side, we see its projection as a continuous wave. But what happens if we look at that exact same helix right down its axis of travel? Well, then it projects as a localized point, a particle. The famous wave-particle duality isn't some deep paradox. It's just a matter of our observational perspective. It's two different views of the exact same continuous higher dimensional object. And this geometric model actually extends to other quantum properties too. The pitch of that 4D helix, how tightly it's wound, is what we measure as a particle's wavelength. The direction it's rotating, clockwise or counterclockwise, that's what we measure as quantum spin. And the Pauli exclusion principle, it becomes this simple, almost mechanical rule. Two helices can't occupy the same space if they're spinning the same way. It's just like two gears trying to mesh. Okay, let's tie all these threads together now and see HBR's ultimate vision, a unified fractal reality. The whole theory really culminates in this beautiful fractal principle of unification, a single fundamental geometry. That 4D bulk and our motion through it gives rise to two seemingly separate domains, the quantum world of tiny helices on one hand and the cosmological world of galactic-scale gravity on the other. And from this one source, all the diverse phenomena we see, from atoms to galaxies, just emerge. And this all leaves us with a final, really provocative question. If hyperbrane relativity is correct, then our entire search for a theory of everything might have been focused on the wrong thing, on the shadows projected on the cave wall. The real unified theory, the ultimate physics, might lie one level deeper, in the rules that govern Q, that state of pure potentiality itself.